Okay, last two problems. So hopefully we remember then that we will be picking for our u the most nestled function. And I have three functions here. I've got the sine, I have the cosine, and then I've got something to the fourth. So the thing that's most nestled is this sine of x because it's tucked inside as the base of the fourth. All right, so we pick the sine x as our u, and then we need the derivative of that u. So again, be really careful. I know we're integrating, which is going backwards, but for a minute, for a second, we're taking a derivative, which is going forwards. So you look at your derivative rules. The derivative of sine is cosine, and that's a derivative with respect to x. So this one is way more simple than it looks. I have u to the fourth, right, because sine is u. So I have u to the fourth, and then this cosine x dx is du. So something looking really difficult, a sine to the fourth cosine x, is really just a u to the fourth du. Okay, nothing to compensate for. I have the entire du here, nothing to multiply in and divide out by. So I am just taking an antiderivative of u to the fourth, which means keep the base of u, add 1 to the exponent, divide by the new exponent, plus that arbitrary constant. Last step is to just turn everything back into x's because our problem is a dx, not a du problem. And I have 1/5 u, which is the sine of x, to the fifth plus c, which of course we would normally write as 1/5 sine to the fifth x plus c. Okay. Last one. So we have three functions here again. We have a tangent, we have a secant, and we've got something squared. So if we're going to follow our normal rule would be to take the function most nestled and call it u. So since the secant is inside a squared, we are going to call the secant our u. There's the bell. Now we're going to take the derivative of that secant. And if you look at your rule sheet, the derivative of the secant is the secant times the tangent. And that's a derivative with respect to x. Now, that makes this really interesting because I'm not going to want to now call this u squared, because if I call this u squared, then what I'm left with is just the tan of x, right? If I say this is u squared, then I have the tan of x dx, not the secant. But if we realize that tangent times secant squared is really the tan times the secant times the secant again, then let me jump to a red pen here. U is the secant, so let me call that u. And then my derivative is secant tan dx, secant tan dx. All of this is my du. So I am integrating u, just a u, du. So again, we have to be able to do our algebra. We had to be able to see the secant squared as the secant times the secant. Otherwise, when you tried to put in your u, you got something that didn't work out for you. So you do follow a pattern and a process, but you've also got to think a little. All right, now I'm integrating u. This is u to the first, so it's a power rule antiderivative. Add 1 to the exponent, divide by the new exponent, plus c. So in terms of x, I have 1/2 u, which is the secant x, squared plus c. Or written the way we will usually write our trig functions, 1/2 secant squared x plus c. All right, so those are our examples, and we will take questions on those next class and work on some more.